Okay, folks, welcome to the second Advanced Space Concepts seminar. Our today's speaker is Professor Colin McInnes, who most of you will hopefully be familiar with. So I'll pass straight over to Colin.
Thanks, Malcolm. First, I'd like to thank Malcolm for organising the group seminar programme. I think it's an excellent venture for us to both to have a range of speakers and also to have the lectures on podcasts, which is something new for us. What I plan to do today is to talk in broad terms about advanced space concepts, do a little bit of speculation, some of it maybe slightly off the wall, but nonetheless to see what could the future hold for space engineering and also for space products and services in the coming decades of the 21st century. Okay, so for a 21st century space systems engineer, which is what we are in our research group, of course, there's three key questions which I want to try and address. The first one is innovation, the idea of progress through technical innovation, and looking back at the past and trying to see what does that tell us about how the process of innovation works and what does it hold for the future of space engineering. Then talk about products and services, and that's what can future space systems deliver over the coming decades. And then the last section, which is when we kind of take the gloves off, if you like, and kind of throw caution to the wind and speculate about advanced space concepts and discuss, are there limits to the future of space systems engineering? So I think these are three very key questions for 21st century space systems engineers. Okay, so the first topic is technical innovation. Technical innovation is just another name for science and its application through engineering. And it has been, I would argue, it's been the most successful outcome of the human enterprise in the past few thousand years. It's been the understanding of the way the world works and being able to exploit that knowledge through engineering, through technical innovation, to improve the human condition for all of us. In terms of space, the development of space can measure of advancement, if you like, over time, seems to follow an S-curve, and the S-curve is something which is typical of all technical innovations. Okay, there's a pioneering phase, if the case of space. That was the late 18th century. The early 20th century, the great pioneers of spaceflight such as Konstantin Tsiolkovsky, who were really dreamers of their time, decades ahead of what the technology could deliver. But nonetheless, that was the start of the S-curve, the innovation curve for space. There's then, moving on, there was the kind of early experiments in space hardware, Goddard, Oberth, and von Braun, of course, and they were translating dreams into engineering reality. Then, of course, things really took off. The exponential curve really kicked in the late 1950s with Sputnik, and then a rapid advance through applications of space and communications, the Apollo program, and then into deep space. And going from the pioneering phase into the kind of early experiments of the 20th century, this knee, if you like, of the exponential curve was incredibly short, astonishingly short, going from a standing start to landing in the moon in a few very short years and reaching the outer solar system, a truly astonishing rate of engineering progress. Then go through telecom satellites, Ariane space, Ariane being used for commercial satellite launches, going from the government-funded flags and footprints of the Apollo era into the actual practical and commercial realisation and exploitation of space. The Space Shuttle program, which of course this is continuing, the Mir space station, and through into the International Space Station. Now, depending what metric you use, how you measure progress, you could argue that we're now approaching the top of the S-curve. And the rapid exponential phase seems, at least, to be slowing somewhat and perhaps starting to plateau. So that's where we are today, I would argue. But of course, that's not the end of the story. It's just the beginning of the story. Now, what I don't plan to do is make specific predictions of what space can deliver in the decades ahead. And there's a whole range of perils of prediction, as I would call them. And the root cause is in human psychology, in that humans tend to think in a linear process, whereas technical innovation follows an S-curve. It follows the pioneering phase, the rapid exponential growth, and then saturation, where the pace of progress seems to slow down, at least temporarily. So one consequence of that, of course, is we tend to have near-term over-optimism. And this is classic of everything from space to the dot-com bubble in the IT industry. Okay, we tend to expect far too much in the long term, but in parallel to that, we tend to lack long-term vision. We totally underestimate what technology will deliver if we look far enough ahead. There's no units, of course, in the time scale here. This could be years, could be decades, could be centuries for some types of engineering. A couple of examples of near-term over-optimism. This is from 2001, A Space Odyssey. For those of you who were born after the 1990s, this was a science fiction film from some years back, still popular, you may have seen it. And one of the key technologies in 2001 is HAL, is the artificial intelligence computer, the AI system. And this is a beautiful example of the near-term over-optimism of the 60s. And HAL says that it became operational in Urbana, Illinois, the 12th of January 1992. Well, I remember January 1992 distinctly, because I sure as hell didn't have a HAL on my desk. I had an Apple Mac. This is what Apple Macs used to like, circa 1992. Fantastic machines, but they didn't talk to you. So, near-term over-optimism. Our linear thinking tends to go a little bit too fast to begin with. But the flip side, of course, is that in the longer term, we tend to lack vision. Now, here's a fantastic quote, not from Harold Wilson. This is from the Department of Economic Affairs of the Wilson government in 1965. Basically, what they're trying to can the UK space launcher programme. They did it successfully, and here's one of the justifications: that there may be a possibility of long-term interest in TV transmission by satellite, but this is never likely to be economic. So, January of this year, B-Sky-B, booming business, built directly on direct broadcast satellite TV. Now, I'm sure Harold Wilson or the Department of Economic Affairs in 1965 certainly went with the long-term vision to realise just how astonishing the penetration of space technology was into consumer services, such as direct broadcast satellite television. So is innovation long-term linear? This is a really important question for us, because if we are trying to speculate on what the future holds for space engineering, or any technology for that matter, then we better have a fairly good handle on how innovation progresses. Okay, so we could have this S-curve, where we have the pioneering phase, the exploitation phase, and the saturation, where we've used up the initial good idea, the initial innovation. But of course, that can just add on to a new innovation. So we learn from innovation 1, and innovation 2 becomes even better, and it continues our measure of advancement. And you have these kind of exponential curves which flatten out. If you join together, you could draw a straight line through them. So is innovation linear?